Building a production-ready AI workflow, from data collection to model deployment and monitoring. Welcome to today's video, where we will embark on a comprehensive journey through the entire process of building a production-ready AI workflow. From the initial stages of data collection to the critical phase of model deployment and monitoring, we will explore the best practices, tools, and strategies needed for successful implementation. If you are involved in AI and machine learning, or if you are simply curious about how these technologies come to life in real-world applications, you are in the right place. So, let's dive in. To begin, let's focus on the very first step, data collection. Data is the lifeblood of any AI project. Without high-quality data, the results and effectiveness of your AI models will be significantly compromised. Therefore, it's crucial to gather relevant, diverse, and high-quality data that reflects the problem you aim to solve. Start by identifying the data sources that are most pertinent to your project. For some applications, this could mean using public datasets available through platforms like Kaggle or government databases. For others, it may involve collecting proprietary data from your organization or even scraping data from websites if permissible. It's important to consider both structured data sources, such as databases, and unstructured data, like text from social media or images. Once you've identified your data sources, the next step is to set a clear purpose for your data collection efforts. Are you trying to predict customer churn, classify images, or analyze sentiment in text? Understanding the end goal will help guide your data collection strategy. Tailor your data collection methods to ensure that you gather the most relevant data points that will help your model learn effectively. In many cases, data collection involves cleaning and pre-processing the data to make it usable. This includes handling missing values, removing duplicates, and normalizing or standardizing data. For text data, you might need to tokenize sentences or remove stop words. For image data, you may want to resize images or apply transformations to increase data diversity. This pre-processing step is crucial. It sets the stage for how well your AI models will perform. Once your data is collected and cleaned, the next important phase is data exploration and analysis. This is where you will perform exploratory data analysis, or EDA. EDA allows you to visualize and understand the dataset's characteristics, uncover hidden patterns, and identify trends that might not be immediately obvious. Tools like Pandas, Matplotlib, and Seaborn in Python are invaluable for this phase. By creating visualizations such as histograms, scatterplots, or boxplots, you can gain insights into the distribution of your data, relationships between variables, and potential outliers. After thoroughly understanding your data, the next step is feature engineering. This process involves selecting, modifying, or creating new features that will enhance the performance of your machine learning model. A good feature set can significantly improve the model's accuracy and generalization. For instance, if you are working with a dataset containing timestamps, you might create new features such as day of the week or month to capture seasonal trends. Feature engineering often requires domain expertise, as understanding the context of your data can lead to better feature selection. Be prepared to iterate through this process, experimenting with different features to see which combinations yield the best model performance. With your data prepared and features engineered, it's time to move on to model selection and training. Choosing the right algorithm is vital to your model's success. This decision depends on the complexity of the problem, the nature of your data, and your specific objectives. For example, if you are dealing with a classification task, algorithms such as logistic regression, decision trees, or more complex models like neural networks might be suitable. The training phase involves splitting your dataset into training and testing sets, typically using a ratio like 80/20ths or 70/30ths. The training set is what your model learns from, while the testing set evaluates its performance. During training, adjust hyperparameters to optimize model performance. Techniques like grid search or random search can help you find the best combinations of these parameters. Once your model is trained, the next step is evaluation. Use metrics appropriate for your specific problem. For classification tasks, metrics such as accuracy, precision, recall, F1 score, and ROSAUC are essential. For regression problems, mean absolute error, mean squared error, and R-squared are commonly used. Evaluating your model's performance on the testing set will provide a clear picture of how it will perform on unseen data. After evaluation, if the model meets your performance criteria, it's time to think about deployment. Model deployment is a critical step in bringing your solution to life. There are various deployment options available, including on-premises solutions, cloud-based platforms like AWS, Azure, or Google Cloud, and edge deployment for IoT applications. When deploying your model, consider how it will integrate with existing systems. Will it be a standalone solution, or will it need to communicate with databases or other APIs? Ensure that you have robust APIs in place for serving predictions, allowing users or other systems to access your model seamlessly. Before launching your model, conduct thorough testing in a staging environment to validate its performance under real-world conditions. This includes verifying the prediction accuracy, latency, and resource consumption. Once you are satisfied with the performance, you can proceed with the full deployment. However, deploying your model is not the end of the road. Post-deployment, ongoing monitoring and maintenance are essential to ensure that your AI solution performs effectively over time. Models can degrade due to various factors such as changes in the underlying data distribution, also known as model drift. Regularly monitor key performance indicators and retrain your model as necessary to maintain its accuracy. Implement logging mechanisms to capture prediction data and collect feedback from users. This feedback loop can be invaluable for understanding how the model is performing and identifying areas for improvement. Additionally, consider setting up automated alerts for when performance drops below a certain threshold, enabling you to take swift action to address issues. In conclusion, building a production-ready AI workflow involves several critical steps: data collection, processing, exploration, feature engineering, model selection and training, deployment, and ongoing monitoring. Each phase is interconnected, and success in one stage can significantly impact the next. As you embark on your AI journey, remember that iteration is key. The process is rarely linear. You will likely find yourself revisiting previous steps as you refine your model and adapt to new data or business needs. Stay updated with the latest advancements in AI and machine learning, as the field is constantly evolving with new techniques, tools, and best practices emerging regularly. Finally, don't underestimate the importance of collaboration. Engage with domain experts, data engineers, and software developers throughout the process. Their insights and expertise can provide you with valuable perspectives that enhance your project's success. Thank you for joining us in this in-depth exploration of building a production-ready AI workflow. If you found this video informative, please give it a thumbs up, subscribe for more content like this, and share your thoughts in the comments below. What challenges have you faced in your AI projects? We'd love to hear about your experiences and any topics you'd like us to cover in future videos. Until next time, keep innovating and exploring the world of AI.